There's one part left to 5.2, which I wanted to finish up with today, and that's working with trig integrals that involve in some way a natural log. So I want to show you a couple ones that come straight from what we did previously, and then a couple new things that we're going to kind of add to this. So the first ones, these are ones really similar to what we talked about earlier in this lesson with this du over u notation. That's what we're looking for. So we're hoping that we can get u to be the denominator. Often with the trig ones, you won't look at it like with the x's where you can see that you have a bigger degree on bottom. You'll just kind of see trig on the top and trig on the bottom and kind of cross your fingers and hope that you can let u be the bottom and du can be the top. The derivative of 1 plus sine 2x is 2 cosine 2x. The reason for the extra 2 is that's the derivative of the angle. So you derive the trig, derive the angle. We don't have that 2 in the original integral, so we're going to divide both sides by 2, giving me a 1/2 adjustment. It is a du over u integral, which gives me 1/2 the natural log of u, which is 1 plus sine 2x. And we'll just leave our answer like that. Not much you can really simplify with that. Same thing with the bottom. Again, your u, you are hoping it is the bottom when you're working with rational integrals. Derivative of that, the derivative of cotangent is negative cosecant squared. We don't work with cosecants and cotangents very much. You actually have negative cosecant squared, including the negative, so no adjustment at all. So this is just a very straightforward, perfect du over u. So you get the natural log of 5 plus cotangent theta plus c. So these are applying the du over u from the beginning of the lesson, and it's also using some of your trig derivatives from chapters 2 and chapters 4, or chapter 2 when we did our trig derivatives. So here's what's new today. So we have what's called single trig integrals. So we currently know 6 things that we can integrate with trig. The only ones that are actually, I would classify as single trig integrals are sine and cosine. So these first 2 in this list that you're looking at, we've worked with before. We know the integral of sine is negative cosine. We know the integral of cosine is sine. Those we started at the beginning of chapter 4. We reviewed again at the end of chapter 4, and they're still showing up. The other 4, though, we have not worked with yet. We have never talked about what's the integral of just tangent. We've talked about secant tangent, but not tangent alone. We've never done just cotangent. We've never done just secant. We've done secant tangent, we've done secant squared, but we've never done just secant, and we've never done just cosecant. So I'm going to leave this up there for a second. You may want to pause the video because you do want to have these down. These are the last trig integrals that we'll work with here. With all of these, since they are in terms of u, you have to identify your u and your du, and you may need to make an adjustment for du. So your u in this case, these are all ones where your u, I don't want that letter there, is your angle of your trig function, and du is hopefully there, or we can quickly adjust to get it there. Again, as we mentioned, if you integrate to get a co-function, it's negative. We've actually talked about that memory device before. So you'll notice there's a negative here because it's a co. You'll also notice there's a negative here because it's a natural log of a co. And there's a negative here. So again, that same rule when you integrate, if you get a co-trig function, it's negative. That doesn't change. So I want to talk about the third and fourth one, the tangent and the cotangent one, because these can be hard to remember because, again, there's so much crammed into your brain right now. If you don't want to memorize that the integral of tangent is negative natural log of cosine, you actually have a backup plan, and that backup plan is what I listed here. We could rewrite tangent as sine over cosine. We could do a u sub. We would let u be the bottom. Derivative of cosine is negative sine, so there'd be a negative adjustment, and we would get negative natural log of u. It would be a du over u in that case, negative natural log of cosine. So it's totally up to you whether you want to just remember that the integral of tangent is negative natural log of cosine of that same angle, or you want to have your backup plan in place of saying, well, I know it's sine over cosine, and I can do a quick u sub to get there. Same thing with cotangent. Here's your backup plan. If you don't want to memorize that it's the natural log of sine, and really because it's not a super common question, it's probably not worth spending a lot of time memorizing this. However, if you want to get there instead, just kind of work through with your common knowledge, you could rewrite cotangent as cosine over sine. We know that relationship, that identity. Let u be the bottom, du is the top, perfect du over u, so it ends up just being the natural log of sine. So the third and the fourth one, while they are new, there is definitely a workaround so you don't have to memorize them. Unfortunately, there's not for the fifth and sixth. So you could either hope and pray that they never show up on the AP test, which they may not. They're pretty obscure. Or you could try to memorize, if anything, I would memorize secant. I feel like that's one's way more common than the cosecant, just in general. So the way that the integral secant works out is it ends up being the natural log of secant of that angle plus tangent. Secants and tangents always go together, so hopefully that helps your memorizing. And then the integral of cosecant is negative, because it has a co in it in the result, natural log of cosecant plus cotangent. The likelihood of that one showing up on the AP test is incredibly low. Secant, maybe a chance. The ones in the first column, way more likely to show up on the AP test. Not a guarantee, but as far as likelihood, the likelihood kind of decreases as you go from 1 to 6. So let me show you some examples with these. And it's kind of nice if you have them written down, you can just kind of look at your what you wrote down and use it as a reference as I'm going through these. So tangent, again, if you don't want to remember tangent, you could write it as sine over cosine and do a u sub that way. If you do remember, the one thing you have to do no matter what is you are going to have an adjustment, because the angle is your u, 7x. The derivative of that is 7, which we don't have anywhere else in the problem. So we have a 1/7 adjustment, and it is a tangent u. The integral of tangent is negative natural log of cosine. And again, if you don't remember it, you could definitely go off to the side and say, you know what, I'm going to call it sine of 7x over cosine of 7x and go from there. I kind of do a hybrid. I start that, I write sine over cosine, and I feel like I'm halfway through the u sub when all of a sudden I'm like, oh, that's right, it's negative natural log of cosine. Cotangent is, you could either write it as cosine over sine, or you could go straight to, let's let u be the angle. If you don't like thetas, you can make it x's. Derivative of 3 theta is 3, so I'm going to do a 1/3 adjustment. It is a cotangent. The integral of cotangent is positive natural log of sine. Good way to remember that it's positive is you don't get a co in your answer. And then the number one mistake students forget is the 1/3 adjustment. So look for those little adjustments. Sometimes if these are multiple choice, you can kind of look at it and it'll like get your memory going, like kind of just kick in your brain what's supposed to happen, and you'll see the natural logs like, oh, that's right, that's what happens. But just watch for things like the adjustments. Our last two. Secant, I said, is not super common, but probably more common than the cosecant one. So your u is x over 4. It's your angle. The derivative of that is 1/4, because remember, x over 4 is just 1/4 of an x. Your adjustment this time is actually times 4, because we want to get rid of that 1/4. So it's a 4 and then the integral of secant. So your integral of secant is the natural log of secant of that same angle plus tangent of that same angle. Working backwards on these are really ugly. Like, you could derive what's there and you would eventually get what you started with, but it's a really complicated path to get there with identities and some simplifying. So I usually don't take the time to do that. And then our last one, our definite integrals. Let's assume that we can't use a calculator, because obviously if we could, we'd just grab it and do math 9. But there is an identity you should recognize here. You should know that 1 plus tangent squared is secant squared. The square root of secant squared is just secant. So we actually get to it looking just like the one we just did. Slightly easier in that there's no adjustment to worry about, but we are going to have boundaries to work with when we're done. So we get the natural log of secant plus tangent, and then we're going to put our boundaries in. So again, we're kind of going under the assumption that you can't use a calculator, so we're going to leave our answer in a pretty exact, not too simplified form. So we're going to have the natural log of secant of pi over 4 plus tangent of pi over 4 minus the natural log of secant of 0 plus tangent of 0. Running out of room there. So secant of pi over 4. Secant is the reciprocal of cosine, and you should know that the cosine of pi over 4 is root 2 over 2. So the secant would be just flipping that fraction. So you would get 2 over root 2. The tangent of pi over 4 is just 1. It's the simplest tangent you can probably come up with. And then minus the secant of 0 would be the reciprocal of the cosine of 0. Cosine of 0 is 1. The reciprocal of that is still 1. Tangent of 0 is actually 0. What is really nice with this one is that whole piece after the minus sign, the natural log, you end up with just the natural log of 1. That is 0. This is as far as you could go if you were not allowed to use a calculator. If you were allowed to use a calculator, you would get an incredibly ugly decimal because of a radical and a natural log all kind of coming into play. So it may actually be simpler. Granted, it'd be nice to have a calculator just to be done real quickly, but it's probably simpler to leave your answer like this than to write the decimal. So that is the end of 5.2. So now you can integrate all different things with natural logs from your basic all the way to your trig.